let's start again. My name is Jakub Kozłowski. I came from Poland. I'm a Scala developer at Scala, a consulting company in Poland. And today I'm going to talk about, wait, that's the wrong title. I'm going to talk about, is it Scala Z or Scala Z? And I hope that at least one person here can answer this question. I think that's John. John, what's the answer? Scala Z. Okay, because I'm going to need this at some point. So the real title is, of course, Fantastic Monads and where to find them. It's 2.1 because I just added some minor things since the last time I gave this talk. And I don't think they will break any of your minds. So that's non-breaking. Okay, so, oh yeah, and before we begin, I would like to thank the organizers for allowing me to speak here. It's my second time in Oslo, and it's perfect so far. Exactly as I remembered it. So, let's go, and let's see how to find fantastic monads. So what we're gonna do in this talk is write a simple HTTP app. Like, it doesn't matter what the technology is, it's just something that I use. And it's going to be a backend for a book library system, like with reservations, and it's gonna have some nasty validation. Of course, it's not going to be as nasty as in the real world, but it'll still be quite nasty. And at some point, we're gonna decouple our application from futures, because that's what we want to do, for reasons I will mention later. And it's done. So I already did this, like in the new Avengers movie. Anyways, on the left side, you can see what it looked like before we got rid of futures. So we have a book DAO with one method in this slide, but there are more in reality. It finds all the books, returns a future of list of book. Then we have a service that calls that DAO method directly. And then we have a roots class that has dependency on this book service and makes a call in the directive for the all prefix. Sorry. And on the right side, you can see that the biggest difference is, of course, that future is now gone. Even the import is gone. Like, this is, you can see it's gone. It's not there. But the future is now just an F. This weird thingy here that I think was mentioned at least a few times in this conference, so I don't have to explain it anymore. So it's, of course, a higher candidate type. So bookDAO is parameterized on a higher candidate type, F. And the same goes for book service and main roots. There's a trick in the slide, like the right side wouldn't really work without something else because of the genericness of F, but we'll go through how to get that working in a while. So before we proceed to the next slide, let's think about why do this? Like, why decouple from futures? Because we've learned in the beginning of our Scala adventures that future is a very nice thing. It's pretty cool. You can flatMap on it, map on it, and it's monadic, kind of, but not completely. So decoupling from futures will allow us to avoid using things like future successful, which is quite often found in code bases working with futures directly. Because sometimes you want to flatMap on something and you don't always want to construct a new computation, just want to return a value wrapped in a future. So that's what you would use. Same goes for future sequence or future traverse, which are quite commonly used methods from the future companion object that you would use to iterate over a list of some items and create futures for all of them and wait for all of them. Yeah. And if you are using at least one of these with normal Scala without any cool things like cats or Scala Z, then you pretty much don't have a choice. You don't have a simple way to abstract over it. You just have to call these methods directly or create your own new abstraction that will just be something that we already know. So this wouldn't be so bad if you were to use futures forever. But as we all know, there are some alternatives. Some are better. Maybe all of them are better. Who knows? But if we don't couple ourselves to features, we can change the implementation easier. And that allows us to mock our dependencies easier. For example, you might want to work with some prototype of your application that you will then swap in for a real implementation. So your database will be in memory, for example. And if your database is in memory, you don't really need to have an effect over the calls. You don't really always need a feature in your in-memory database. The same goes for tests. Like, how many times have you done like future value or await in your Scala test code? You could just avoid that if you were to abstract on the future. And if you want to refactor to task or the IO monad from cats from Scala Z, then not being tied to futures will also help and make that a no-brainer. So before we are able to abstract on something like future or any other effect that you would use, we need to know about some things. So the first one is type classes, and I hope that everyone knows what they are by now. So if you don't know type classes, please raise your hand right now. Great, nobody. Oh no, there's one hand. Well, sorry, you're an outlier. So we need to know a few of the type classes that are there in existence. The first one will be functor, then applicative, monad, and traverse. I think these are like the most important type classes to know if you're doing this kind of thing, from my experience. And I hope to explain how they work in a sec. We're going to use cats in this presentation. I'm sorry, it's not going to be Scala Z. So I guess there was just one Scala Z presentation during this conference so far. So cats is a type level project. Type level is like an organization that builds open source software that's easy to contribute. And yeah, you can read the manifest or the description on the website. But cats is one of their projects. I think one of the most popular. And cats is described, or used to be described as a lightweight, modular, and extensible library for functional programming. And this is inspired by Scala Z, sorry. So it started as, I think, a fork of Scala Z, but it's a bit different now. Anyways, what it does is provide type classes, like functor and monad, instances for them, for the standard library classes, and their own data structures, and also instances for those data structures. And some additional syntax that you would use, but that's not necessary here. So this will not be a cats tutorial. I don't want to just show how to use this thing and this thing, because there are like thousands of tutorials like this. I can give you some links. So there's some excellent documentation, at least I thought it was excellent, on the official website of TypeLevel. And there's a quite helpful chat room on Gitter. And yeah, if you have any questions after this talk and I'm not able to answer them, you can find this guy. He's somewhere here. Okay, he's hiding. Anyways, yeah, that's Luka. And he's one of the maintainers now. So, this is supposed to be an intro to type classes, but we know them. Yeah, so the next part, type classes in cats. As I promised, there would be functor. So functor is basically a trait, a type class that has one higher-kinded type parameter called f. And all that you need to implement it is, oh yeah, these snippets may not be exactly how they look like in cats. Some may be simplified. I think this one is not. Anyways, so the only thing you need to do to implement your own functor instance is provide a map function that takes an f of t and a function from t to u and returns an f of u. So with an example, you could say that you have a box, the f is our box, and you have a, I don't know, let's say you have a piece of candy inside that box. Okay, this is not a good example. Okay, let's use pieces of paper. So we have a box with a piece of paper. The piece of paper is our T. And we provide a function that writes something on this piece of paper. And then it's written piece of paper. And then you'll end up with a box with a piece of paper that has something written on it. Maybe that's not the best example, but now we'll have something more practical, ints, because everyone loves ints. Everyone uses them. So if you have an f of ints, you want to make every int inside bigger by 1. Then you can do something like this, summon an implicit functor instance with this syntax, and just call map with ints and a function that adds 1. The type doesn't need to be the same in the result, but it is here. Or you can use the alternative syntax, the better one apparently. You can import cats syntax functor underscore, or just cats syntax all underscore. And then you can do it like you would normally do on a list or an option, which also are functors. And cats provides instances for them. So for example, if you call this with a list of 1 to 3, we'll get a list of 2, 3, 4. And if we call it with an option of 3, a sum of 3 underneath, we'll get sum of 4, which is still an option of int. And if we call it with a none, we'll just get none. So I guess it makes sense. Now applicative. This is for sure simplified, because there will be another layer of typeclasses between functor and applicative. Anyways, applicative is just like a functor. It's an applicative functor, so it has to be a functor. And it actually extends from it in cats. So it adds 2 possibilities for what you had with functor already. The first one is pure. So what pure does is it wraps a single value inside the effect, the f, or our box. So if you had this famous piece of paper and you called pure with some applicative instance, you would get, let's say, a box with a piece of paper. AP is slightly more complex than map. So imagine you have 2 boxes, and one has some value, and the other box has a function inside. And you can't directly access any of these. You can't directly access the value inside the first box or the function in the second box. But given an applicative instance, you can extract these values somehow from the inside of these boxes, apply this function to the value in the other box, the first one, and you'll end up with a box with a new value. And with just functor, this wouldn't work in an abstract way, because you would end up with nested f's, and that's not something you want most of the time. Okay. And now the monad. I previously used like the M word, but I think that everyone is accustomed to the name now, and it's not scary anymore. So let's just use that name. So monad is just like an applicative. It's simplified as well. But it also adds a flatMap method, which is just like good old flatMap from list or option or other data types that you already know. So flatMap takes an f of a function from a to f of b, and returns an f of b. So now, what it looks like it does, you can take a box with a value, apply a function that, take a box with a value, take a function that takes this value and creates a new box, and have the new box as a result. And the more realistic use case is like with applicative, if you had 2 independent computations, like one would be a database call, one would be a network call to some other service. Let's say these are futures for now. You would have 2 futures that were started independently without using each other's results to be created. And given an applicative, you can actually combine these results from the database call or the network call and the network call, and you can handle them together without having a monad instance. But with the monad, it's even more powerful because you can actually make computations depend on each other. You can make one database call, for example, find the object by some ID, and then you can use that ID, that object from the database that you got, and make a network call or another database call or any number of them. Just like in a for comprehension or something like that. So to visualize this structure, here's an image. So f gives you basically nothing. Functor gives you working inside a computation or a result of a computation. Applicatives allows you to compose independent computations, and Monad allows you to compose dependent computations, like computations that depend on each other. And now traverse, which is not, I wouldn't say it's part of that hierarchy. I mean, technically it is still a type class in cats, but it's slightly different than the rest. Traverse only extends from functor, like it's not an applicative, or at least doesn't have to be. And it has one function that's, I think, way more complex than any of the functions we've seen before, called traverse. But before I explain traverse, let me show another function inside traverse that's called sequence. So if you've used like future sequence any time in your life, then you probably know what this is doing. So if you have an f of g of a and you call sequence on it, you'll just get a g of f of a. So let's talk about our example again. So if our a was a piece of paper, our g was a box, like a cardboard box, and f was a room. So we have a piece of paper inside a box, inside the room. And then we call sequence on it. So we basically flip the containers, the effects, outside to the inside. So now we'll have a piece of paper inside the room, which is inside the cardboard box, which is not realistic, I know, but I think you can visualize that at least. So a more a more practical example would be a list of futures, as I said before. So if you had like a list of IDs from a request or from I don't care what, and you want to make a database call or a network call for each one of them, you'll end up most likely with something like this, a list of futures, let's say of strings. And this is not likely what you want. You want a single future to wait on and to return in the request response. So what you would normally do is just call sequence on it and have a future of list. Now traverse is a slightly more abstract version of sequence, in which traverse with a function is just like map with a function and then sequence. So if you had a list of IDs, you might just map to a database call each one of them and then sequence. But you could do both of these steps in a single method call. Just do IDs, traverse, make database call. And the other way around, sequence is just like traverse with identity. And it's actually implemented like this in cats. It's just traverse with x to x. At least that was so yesterday. So now we'll look at the code, like the example that I prepared. Let me just, yeah. Okay, I think you can see exactly what I can see. Okay, great. Let's go to presentation mode. Is the code large enough in the back? Okay, finally. So this is our controller. We'll have, as I said, this will be a book library backend. So we'll have one endpoint for getting all the books that we have, one for adding a book, one for renting a book, and one for renting many books. So if you can guess how rent books is implemented at this point, given the type classes that I mentioned before, please write a tweet and maybe you'll win a t-shirt. The first person who does it will win a t-shirt. Okay, so let's look at how book service is implemented. Or no, let's first look at this. This is the missing part that was not there in the slide that I showed before. And this is just needed because hAkker works on futures. Like if you want to return something else in a complete block, you need a custom marshaller, which is like a serializer. So this is basically just a trick to make anything serializable if it has a conversion to future. This is just like a natural transformation to future. And I have some additional syntax and an instance for task and ID, which will be used later. Okay, so our book service, yeah, and as you can see, find books returns an f of list, not a future anymore. So our book service takes an f and a monad, because we'll have dependent effects. And it has a few methods. And the answer to the question was, yeah, it's implemented with sequence. It could be traverse as well. Anyway, so let's get back to find books, because I'm losing myself now. So find books is just forwarding the call to the DAO. The implementation doesn't really matter, it's just an in-memory, boring stuff. But what matters is that our DAO is implemented with like book DAO of ID. And ID is a specific type alias in CADS. That's just a nice trick of making any type a higher-counted type. So ID of A is A, which allows us to just have a DAO that returns the values inside no effect. So if you see, if you look at this, we have find all that returns f of list. But in the ID implemented DAO, we have just list of book. So there's no more f. I could just do ID of list of book, but it's the same thing. So we have all these methods, like isRented, find by ID, rent book, and save book. They don't do any kind of validation. They just forward the calls to the database or the in-memory map. Come on, where's the service? So find books is just implemented like this. Now something more interesting, add book. Oh no, I'll have to explain something. Yeah. So add book returns an f of validated null with some error and some ID. So without going into too many details, validated is like either. It's from cats. It's like either, except that validated allows you to compose the errors that you have, like the left side. So it's very biased towards the right side. So how we use it is we validate the book. So this will only return a validated null, like validated with a non-empty list of errors. And this is how it looks like. So as I said, this is not a CAS tutorial, so I won't explain this in detail, but we're checking if the ISBN is exactly 10 characters long, and if the name is between 1 and 10 characters. And if we have valid values for both of these, we'll have a book, which is like ID, ISBN, and name. But if any of these fails, like if we have a shorter or longer ISBN, or the name is too long or empty, then we'll have a list of errors. And these errors will compose, as you'll see in a minute. So after we've validated our book, we traverse to DAO save book. And now we have an f of validated null with book create error and book ID, which is returned from save book. Okay, so this is how we add books. Now, how we rent books is, first we check if the book actually exists, and we also check if the book is rented. Because if it's rented, we can't rent it again. So this is sorry. This is the so-called applicative builder syntax. So this is how we compose independent effects in cats. We just do this kind of thing. So this is the computation for finding the existing book. This one for the rental status. And then we use these to either return an error if the book doesn't exist. I think I overcomplicated this. Anyways, so if the book is there actually in the database, then we try to rent it if it's not rented already. So if it is rented already, we just return an error using the pure function. And if it's not rented, we just rent it and map the result to the right. And the result is, I think, just a unit. Yeah. And then we flatten because we would have nested f's. And to rent multiple books, we just do traverse on a list. And it works because rent book returns an f of result. And we actually have an applicative instance for f, because f is a monad here. So if we have monad, we have applicative as well. And you can see that implicit parameter is there. Okay. Okay, so I think I can show an example of how that works. It's in Postman. So is it large enough? Okay. So if you get all the books, oh yeah, I think it's not started now. Let's just wait a second. Yeah, SBT. Come on. Yeah. Okay. All right, so we have two books because that's how I hard-coded it so far. The first one is functional programming in Scala. The other one is functional programming in Java. The second one is rented already. I don't know who rented that book, but let's say someone did. And yeah, these are all the books that we have. If we make any number of requests, that's the same. So let's try to rent a book. Let's try to rent a book with the ID, like, I don't know, this kind of ID. And the book doesn't exist. So I get an error, book not found. So let's try to rent the first book. I think it had the ID 1. Yeah. So let's try to rent that. And it works. I got unit, which is serialized to an empty object. And if I try again, of course, it's book already rented. And if I try to rent the second book, it's just book already rented. So let's try to add a book now. So let's use some invalid values, like an empty ISBN or just a few characters, and an empty name. So I'll get two errors. It's invalid ISBN because it's not exactly 10 characters long, and it's invalid name because it's too short. So if I make the name longer, and let's say it's just called Hello Oslo, I think that's like 10 characters. Now we just get invalid ISBN. And if I make the ISBN valid, like, and the name is too short now, we'll just get invalid name, of course. So if I supply a valid name, I make a request, we got a new ID, beautiful. I'll copy that because I'll need it. And we make a request to the list of books, we of course get the new book inside the list. So now we can try to rent it. So if I supply the ID, it worked, and now it didn't because it's already rented. So let's restart our application. Let's look at the books. Okay, so we have two books again. I'll add some fake books like Hello Oslo, Scala 3, Scala 2. So we have more than one new book. And let's try to rent multiple books, because that's, I think, the most interesting part in this demo. So we'll try to rent the book 1, which is not rented, as we remember, because I restarted. We'll try to rent 2, which is already rented. And we'll try to rent Scala 3, because that's going to be a really nice thing, if it ever comes out. So that's 1 and 2, and this new ID. And let's also try to rent a book that doesn't exist. So for the first one, which was not rented, we got a write, which is what we would expect. The second one was already rented, as you can see. The third one was not rented, so it's write again. And the last one doesn't exist. So if you try again, we should have all lefts, and that's the case. So only the last one is not found, and the others are already rented. So I think this is nothing extraordinarily surprising. So let's get back to the slides, actually. No slides. Come on. Nope. Okay. Macs are weird. So if you want to find out more about cats, I encourage you to read these materials. So there's a blog post from our blog, from Scala. There's the book from Underscore. I don't think it's that new now. It's been like half a year. But then there's herding cats and official documentation from type level. And that's, I think, all of it. So thank you for coming and listening to me. And I hope I encouraged you a bit to use these type classes in real code. It really works. Like, it's not only for simple use cases, and I really encourage you to use it. If you want to look at the slides later, they're here, and the code will be here. And do we have time for questions? I guess we do, yeah. So if you have any questions. Okay, I guess there are no questions this time. So if you have any questions later, you can contact me. Please write a tweet. I really like it when people tweet about the talk. Emailing is even better. And if you want to just look at things, you can go to my old website from like 4 years ago. And please enjoy the rest of the conference.